This building has no steel, no rebar, no modern engineering. It was built nearly 2,000 years ago, and its dome is still the largest unreinforced concrete dome on Earth. Nothing we have built since has surpassed it. Meanwhile, modern concrete starts cracking in 50 years. Highways crumble, bridges need constant repair. We spend billions every year fixing concrete that was poured just decades ago. But Roman concrete has survived 2,000 years of earthquakes, floods, and the relentless pounding of the sea. How is that possible? How did the Romans build something we still cannot match? To understand why Roman concrete is so extraordinary, you first need to understand what concrete is. At its simplest, concrete is a mixture of three things: a binding ingredient that hardens when it gets wet, an aggregate, which is sand or gravel that gives it bulk, and water. Modern concrete uses Portland cement as its binder. You mix it with water, it hardens, and it holds things together. It works well, but it has a flaw that engineers have known about for over a century. It cracks. And once it cracks, water gets in, and the damage spreads. The Romans did something different. Instead of the calcium-based cement we use today, they used volcanic ash, specifically a type of ash found near the town of Pozzuoli, near Mount Vesuvius. The Romans called it pulvis puteolanus. Today we call it pozzolana. They mixed this volcanic ash with lime and seawater. Then they added chunks of volcanic rock as aggregate. The result looked rough. It did not have the smooth finish of modern concrete, but something remarkable was happening inside it at a chemical level. When volcanic ash meets lime and seawater, a chemical reaction begins that does not happen in modern concrete. The aluminum and silica in the ash react with the lime and the salt water to form a mineral called aluminum tobermarite. This mineral grows as interlocking crystal plates inside the concrete. Here is the critical part. When Roman concrete cracks and seawater enters, the chemical reaction restarts. New crystals grow inside the crack and seal it shut. The concrete literally heals itself. Modern concrete does the opposite. When it cracks, the damage only gets worse. The proof is everywhere. Roman harbor walls have been sitting in salt water for 2,000 years, and they are stronger now than when they were first poured. Engineers have tested core samples and confirmed it. The seawater that was supposed to destroy them actually made them stronger. The Pantheon was built in 125 AD under Emperor Hadrian. Its dome spans over 43 meters. It is made entirely of unreinforced Roman concrete, no steel skeleton, no rebar, just concrete and genius engineering, and it is still standing perfectly intact nearly 1,900 years later. The Pantheon's dome is actually wider than the dome of St. Peter's Basilica, which was built 1,400 years later, and the Pantheon did it without any steel. The Pantheon's dome works because the Romans understood something about weight distribution. The base of the dome is over 6 meters thick, made with heavy concrete containing brick and volcanic rock. But as the dome rises, the concrete gets thinner, and the aggregate changes. Near the top, they used pumice, a volcanic stone so light it floats on water. The oculus at the very top, the open circle that lets in light and rain, is not just beautiful, it is structural. It relieves the compression at the crown of the dome, the exact point where the most stress builds up. The Romans solved a structural engineering problem that modern architects study in graduate school. When the Roman Empire fell, the recipe was lost, not because it was a secret, but because the infrastructure that supported it disappeared. The quarries near Pozzuoli stopped operating. The trade networks that moved volcanic ash across the empire collapsed. The skilled workers who knew how to mix and pour it were gone. For over 1,000 years, nobody in Europe could build with concrete. The medieval world went back to stone and mortar. It was not until the 1800s that engineers reinvented concrete, and the version they came up with, Portland cement, was faster and cheaper, but it was not better. And here's the strangest part. The recipe was never truly lost. A Roman engineer named Vitruvius actually wrote it down in a book that survived for centuries. Engineers had the instructions the entire time. They just did not believe that volcanic ash could be the key ingredient, so they ignored it. In 2023, researchers at MIT finally identified the full mechanism that makes Roman concrete self-healing. They discovered that the Romans deliberately mixed their lime at extremely high temperatures, creating small white chunks called limeclasts throughout the concrete. For decades, scientists assumed these white chunks were a sign of sloppy mixing. They thought the Romans had failed to mix their ingredients thoroughly. It turned out to be the opposite. The limeclasts were the key. When cracks form and water enters, the limeclasts dissolve and recrystallize, filling the crack. It was intentional all along. After water, concrete is the most consumed substance on Earth. We use over 10 billion tons of it every year. Roads, bridges, dams, skyscrapers, entire cities built from it, and all of it will start cracking within decades. This matters because the modern world has a concrete crisis. The American Society of Civil Engineers gives the infrastructure of the United States a grade of C-. Bridges, highways, dams, and buildings are cracking and crumbling faster than they can be repaired. If we could make concrete that heals itself the way Roman concrete does, we could save hundreds of billions of dollars in repairs. We could build structures that last centuries instead of decades. Some research teams are already working on this, incorporating volcanic ash and limeclasts into modern mixtures. 2,000 years ago, Roman engineers mixed volcanic ash, lime, and seawater and poured it into wooden molds. They did not have computer models. They did not have chemistry degrees. They had observation, patience, and centuries of trial and error. And they built something that has outlasted every piece of modern concrete ever poured, every highway, every skyscraper, every bridge. And it is still standing, right now, in the center of Rome, waiting for us to figure out what they already knew. The Romans did not just build an empire, they built things that refused to die. And concrete was only the beginning. Next time on Lost Genius, we uncover another Roman invention the world forgot. Subscribe so you do not miss it.